So just consider we are doing welding, and the welding generally we are doing as per WPS. So in WPS, WPS will give the guidelines for uh, what is current requirement, current range, voltage range, traveling speed, so interpass temperature, preheat temperature. So these 4-5 parameters are very important. Suppose if you are doing welding, so before doing welding, we are making the weld preparation. How many people you know the weld preparation? Suppose this is the one plate, and we are making this groove and bevel preparation on milling machine, and so here this is the base metal, this is the base metal, and this is the bevel angle. This also bevel angle. If you are making here one straight line like this, and suppose this angle is known as bevel angle, and this is the bevel face, and this total angle is known as included angle. Total angle is known as included angle, and this total angle is generally 60 to 70 degree. This total included angle is generally 60 to 70 degree, and this bevel angle is generally 30 to 35 degree. Okay, so 30 to 35 degree, and this is known as root gap, and this root gap generally 2 to 3 millimeters. So please remember this root gap is 2 to 3 millimeter. This is the root gap, and this is 2 to 3 millimeter, and this is known as root face, or we can say root height, and this also generally 2 to 3 millimeters. So, and this you just consider, if suppose this root gap is very less, then what will affect on weld quality? So
लाइन पे जाएगा वही नाही नोट्स हे करायचे लेक्चर मध्ये
okay, so if suppose root gap is very less, then when you are doing welding, this weld metal will not enter in this area. So here there are chances to underpeel, or we can say incomplete penetration. Basically, incomplete penetration type of defect will be there, or we can say lack of penetration. Lack of penetration means what? The weld is not completely filled up to here, up to thickness. If there is some gap is here, then we can say lack of penetration, or we can say lack of incomplete penetration. So these defects occurs there. The reason is some electrode traveling speed. Now suppose this is your electrode, and this electrode is melted because of current and voltage, and if this traveling speed is very fast, then deposited material is very less, so you will get incomplete penetration. Suppose current value is less. If current is less, then what happen? There will be less heat input, and you will get less melting point, melting rate, and there are like chances of lack of penetration. So so these are the problems occurs during welding. So that's why many problems are there. Sidewall fusion also there, porosity is also there. We are going to discuss step by step. But main cause of these problems, so you have to remember, we have to do welding as per WPS. So in WPS, we are getting information about the current, what is the current range we need to use for that particular weld, what is the voltage range, is preheat temperature requirement, interpass temperature requirement, electrode traveling speeds. Okay, so weld preparations, the bevel angle, everything is there, root face, root gap, and electrode size also there, type of electrodes also there. So we have to follow, we have to do welding as per WPS requirements. So if you are doing welding as per WPS, there are very late chances to occur defect in weld. So let's discuss here type of defect in welding and how it's look in radiography. Now we'll start one by one. Okay. Now the first is defect technology, and this too often the term defect is used when the word flaw or discontinuity is intended. A defect is a discontinuity which renders a part or product unable to meet the minimum acceptance standards, and discontinuity is an interruption or flaw in a part or product, and that will not affect the performance of your specimen or life of specimen. Then we can say discontinuity means in simple, discontinuity will be acceptable. It will not affect the performance of job or life of job, and defect means it will affect the life or performance of job and it will not acceptable. So we or you will not decide defect or discontinuity. Designer will decide. So as per designer's requirements, we are using the applicable acceptance criteria. And if your job, suppose if any discontinuity is within the acceptable limit, then it is discontinuity. Or if suppose the discontinuity is not within the limit, then we can say defect. Okay, then next, so this defect discontinuity. So now defect or discontinuities are commonly divided between following descriptions. One is imperfect shape. Now suppose there is no any discontinuity, but the shape of the welding is not good, is not meeting the requirement of visual criteria. Then also we can say that is defect. So sometimes cavities are there. So cavity is also not acceptable. So that is also defect. So solid inclusions also there, means slag inclusion, tungsten inclusion also there. So that is also not acceptable. Lack of fusion and penetration also there. Cracks, there are different types of cracks, HZ cracks, centerline cracks, transverse crack, toe cracks, many types of cracks are there. So we are going to discuss in details. So miscellaneous faults also there. So one by one we will go. Now imperfect shape. Now see here, this is the undercut, and in this undercut, where you are seeing undercut, you see here, here it is very clear image. So this is the base metal, and this is also base metal, and this is the weld metal, and here this base metal is melted. Please remember, if the base metal is melted, then we are saying undercut. Okay, if base metal melted, then we are saying that is undercut. So underfill is different. Underfill is different. This is the undercut. Now this is the butt joint. This is the butt joint and this is the fillet joint. Now here, see here, the base metal is melted. So this is also undercut. So here, the undercut, the defect reason, poor manipulation by the welder. Means welder is doing welding, and at the time the electrode movement, electrode direction with respect to weld area, with respect to base angle, or we can say electrode angle, is not properly maintained by welder, and welder's welding speed is too slow. Now suppose the welding is not going fast and the welder is doing welding very slowly, the traveling electrode traveling speed is very slow. So in this case, heat input will be increases. So there are chances to melt the base metal. So welding current too high, that is also reason. If welding current too high, then heat input will be increases and base metal will melt. Incorrect or poor wave. This wave means when you are doing welding, if electrode is moving straight or if your electrode is moving up down, is different. So that is the wave actually. So if your electrode is moving straight, then there are very less chances of undercut. If suppose if you are moving just little bit xy direction, or we can say same as your AC current, like this weaving is different type, no? So there are chances to get the undercut. So here this the next reason, an irregular groove found at the toe of the weld or an previously deposited weld pass. This defect can be found on the cap, in the root, or internal to the weld. Basically this undercut you will get on top also, you will get here also at root undercut. Then we can say root undercut, here we can say cap undercut. This is the shear. This in case of fillet, you are getting here also. Now, this you see here in radiography film, you will see the undercut. This is the base metal. This is the base metal, means here I will make some marking here. You will understand very easily radiography film. Now, suppose I am marking here A identification, and here is B identification. Means this A means this border, and this B means this border. So here, this side you will get here, this A. This border you will get film on this border here. And this B border means here you are getting here. And this distance between this B, A to B, that is the width of the weld, and this is this one. Okay, so so this here, now this is the throughout the length, and this is the this root gap, root here. This is 2 to 3 millimeter area, and this is the root area. This white indicates the root area. This is whole root area. Okay, and this side undercut you will get here the dark line, and you will get at the between base metal and weld metal, and this we can say toe area, TOE, toe area. Okay, so and this side also, if here is no undercut, that's why nothing is there. And also see, this is the wires also you've seen on radiograph, this white wires, small wires. So that we will see later in radiography what is the purpose of that wires. That is actually image quality indicators wires, we will see. So now you understand, right? The undercut means basically the weld base metal is melted here. So that this is the root undercut. This is the root undercut. This is the cap undercut. So, so please remember, I will share this slide also after this course. So you please go through that. This undercut we can best NDT method is visual testing. For this undercut detection, radiography also we can detect penetrant testing also, magnetic particle testing and ED current testing. But you always remember the visual inspection is the best techniques to detect undercut. Because visually we are going to see why radiography and this penetrant testing is required. If somebody not done visual inspection, then definitely you will get in radiography. This overlap, see the weld shape is not properly. So this is like this. So generally shape will be like this. So if shape is like this, then it's overlap, and this overlap is not acceptable because in future there are chances to generate crack in this region. So that's why this overlap is not acceptable. The reason for overlap, this is known as overlap. The reason for overlap, too low welding current. If welding current is too low, then heat input is less. So molten metal is not in proper liquid form. So there are chances to get this type of overlap. Okay, then welding speed too fast. This is also reason. Poor manipulation by welder means welder is improper skill, or we can say less experience, because manipulation of electrode also is very important. Then contamination of parent metal, gravity. So these are the reasons for weld overlap. This weld overlap also not acceptable. And this overlap can be detected by visual inspection, magnetic particle testing, and liquid penetrant testing. But the most important thing here, the first is visual inspection. So visual inspection is main thing. Then root concavity. See here what happens. So this root, the weld metal is not filled up to here. So this curvature you get because of after melting and during solidification, this area goes inside here because of shrinkage. That's why this goes inside. So this is root concavity. It is similar of root penetration. The location is same. This root concavity can only occurs after full root penetration. Means this you will get during full penetration weld. Also another name is suck back. Suck back is another name. Now causes of that excess backing gas. So what is backing gas? So generally if you are doing pipe welding, so in pipe welding, if you are doing welding without any gas, then what happens in environment also there are different gases. So that gases will damage your weld. Okay, suppose if you are doing this welding here, and this is one pipe, this is one pipe, and you are doing welding here. Okay, so so sometimes we are sending inside there is some inert gases and outside also. So that gases will protect your weld metal from surrounding gases. So that is so you will get less defect, or we can expect weld without defects. So if suppose that gases whatever we are using, if that amount is excess, then there are chances of this root concavity. Then incorrect welding procedure. This is also chance. If suppose your WPS is not correct, then you will get this type of defect. So gravity also matter. Excessively large root face. If root face is high, means we saw the root face, means here this is the weld preparation and this is the root face. If this height of root face is high, this means height is more, then so what happens? This molten metal comes here, and after that it will shrink like this, and you will get this suck back, or we can say root concavity. See this root concavity, and here you will get at the center. So this is the dark line at the center. Basically, the width is 2 to 3 millimeter, and this is also not acceptable. So root concavity also not acceptable. Okay, so root concavity may be found by the following method: visual inspection, ultrasonic testing, long range, guided ultrasonic, and radiography. Basically, this root concavity you will see visual inspection. But in case of pipe, then inside area is not visible. So we can use boroscope or endoscope to check the inside area of the pipe. And if you don't have that in boroscopy or endoscopy, then with the help of ultrasonic testing, we will find the root penetration or root concavity. And this you are going to learn in ultrasonic testing, how to detect root concavity, how to detect lack of penetration. So this long range guided ultrasonic, basically this using to check the long piping. If suppose we have in refinery, gas pipelines and also petroleum pipelines are there in India also. So the pipeline that under corrosion, under insulation, right? So it's not possible to remove insulation for inspection purpose. It's costly. So that's why they are removing the insulation at particular area, and we are keeping the probe there. That is long range UT, not like our UT. And you will get any indication up to 5 to 6 kilometers also. If anything between up to 5-6 kilometers, you will get the indications. So that is known as long range guided ultrasonic testing. And this is basically they are using for pipelines of gases or petroleum based products, and which is under insulation. This is excess root penetration, and see this is the extra weld metal here, and because of that so we have to get the problem in weld. So it's not acceptable, excess root penetration. This is also visual defects, so we have to detect visually, or if not visually, then we can use ultrasonic testing also. We'll keep the probe here and you will get this height. This total thickness is more than this thickness. So this thickness is 10 millimeter, and this suppose this more, that means here is problem, and this cap also. Okay, so this excess penetration, here you will get weld like this. So it's not acceptable generally. The minimum penetration should be up to thickness. Suppose thickness is here is sufficient, up to here is sufficient. This is the extra material. Okay, so this reason is to slow a welding speed. Then welding current too high. If welding current is high, then melting rate is high, and you will get extra material very fast here. So root face too small, root gap too large. If root gap is large, then there are chances to get down more molten metal. Electrode diameter too small as compared to root gap. So we have to check root gap, and here we are not choosing the electrode. If you are using the electrode as per WPS, you will not get such type of problems. If you are, that's why the WPS is there, to reduce the defect in the weld. So the purpose of WPS is to reduce the defect in during the welding, and also you will get the strength what's required. See here in radiography film, you see this white marking. Why? Because of this white, the extra thickness is here. That's why you will get the white image, and this is also not acceptable. So excess root penetration we are detecting in visual inspection, not in magnetic particle testing and radiography. It's not necessary. Visual inspection is sufficient. But suppose sometimes pipe and you don't have any boroscope or endoscope, then we are doing the radiography, and that time we are detecting in radiography also. Or suppose if you want to detect in ultrasonic testing, we can detect also. Then lack of fusion, lack of penetration and inclusion. Now see, here is the lack of penetration. This weld is not entered here. So here is the gap, and this is known as lack of penetration. So lack of penetration is the failure of the weld metal to extend into root of the joint. It's not extended here up to root, right? Here only here. This weld metal is up to here, and this remaining root gap, there is no any weld. So this type of defect is known as lack of or incomplete penetration. Now, the reason lack of root penetration, too large a root face, means here this trait is known as root face. If the generally it's 2 to 3 millimeter, but suppose mistakenly sometimes 4 to 5 millimeter, then there are chances to get here the lack of penetration. Then too small root gap. Now this root gap, if suppose generally 2 to 3 millimeter is necessary, if suppose this is very less, 1 or 2 millimeter, or sometimes they are not keeping also by mistakenly, so you will get the discontinuity, means incomplete penetration here. Then the welding current too low. If current is low, then melting rate is low, and if melting rate is low, then this weld is not filled up to here, and you will get the problem. So failure to follow. Then welding speed too fast, means welder is doing welding very fast, means electrode traveling speed is very fast, so you will get incomplete penetration. So failure to follow welding procedure is very important here, means we have to follow that electrode traveling speed, currents, weld preparation, all these things. Weld preparation means root gap, bevel angle, root face. So all these things should be as per WPS. Now, lack of root penetration, we can detect first with the help of ultrasonic testing, radiography, magnetic particle testing, penetrant testing, all techniques we can use. But lack of root penetration, mostly if suppose in case of pressure vessel, we can just see visually also if you are doing internal inspection, or suppose if you are using boroscope, endoscope, then also you will get by visual. But if suppose if you don't have the boroscope or inside area is not accessible to you, then we have to use radiography or ultrasonic testing for lack of root penetration. So magnetic particle testing is very rarely used. So this first two is ultrasonic testing, or we can use radiography. So this lack of fusion is a lack of joining between the weld metal and parent metal, or between weld metal to weld metal, lack of inter-run fusion. So basically there are two types of lack of fusion. One is, see here, this is the base metal and this is the weld metal. And if these two not joined or not fused together, we can say lack of fusion. And what was the other? So inter-run fusion, lack of inter-run fusion. That means if suppose you completed this root run and this is the second run, this is the second and this is the first. If suppose this border between first and second, the junction, the boundary between first and second run is not fused together, that is known as lack of inter-run fusion. Generally, this weld we are not completed in one weld, one run. We are doing this first run, second run, third run, fourth run, like this. Now here, this is the lack of fusion here. We can say lack of sidewall, because this is the sidewall. That's why our name is lack of sidewall fusion here. Now see this image here, you will see here in the radiography, and not at the center. If anything at the center, you will get in center. If here, you will get this side. If here, you will get here, not at inside the weld. So when you will get inside the weld, if suppose weld is here, so your defect is here, this sidewall fusion or other any defects. Now see, this is the lack of root fusion. So one side this root is okay, but the other side root is not okay. So this defect is known as lack of root fusion. So lack of root fusion, root gap too wide. This is the reason, means if suppose this root gap is too high, then welding speed too fast, means electrode traveling speed is high. If current is low and contaminated material, because of that you will not get fusion. So incorrect size of electrode also important here. If suppose your root gap is more and you are using very small diameter electrode, then you will get such type of problem, or sometimes opposite also. If your root gap is small and your electrode is bigger size, so poor manipulation of electrode. So, but so these are the some of the reasons here. Cause for that, and this here you see here, this is the lack of root fusion, and the image you will get like this in radiography. See, this is the image here, you will get like this here. The line is given, straight line is there. So that is lack of root fusion. Now this is the porosity, means small holes you will get on the weld, and this because of if electrode having any moisture content, or there is moisture in the air, or your job surface is there is moisture, so you will get during welding the heat will be generated and the moisture will evaporate and you will get gas, and because of these gases you will get small holes. So this is the reason for porosity. So common defect caused by air or gas entrapped in the weld may exhibit itself as a single pore, group or cluster, scattered or random, aligned or linear. See, this is the cluster and aligned porosities. So sometimes this is 1 or 2 or 3, we can say random. So typical cause, moist or damp electrodes and parent material, atmospheric condition, so contamination of welding surface, poor welding housekeeping, preheat. If preheat, why preheat is necessary? If you are doing hitting the plate before start of welding, if there is any moisture, it will evaporate. So there will gases will evaporate, and everything will be we have to done before actually melting the before doing the weld. So the preheat is important. If you are doing preheat, then moisture or any other things from the welding surface will means moisture will be removed with the help of preheat, and after that we are doing welding. So see, this is the porosities, and you are seeing like this. This is aligned porosities, we can say. And this porosity we can detect by visual inspection, liquid penetrant testing. Here, see, magnetic particle testing is very difficult to detect. So that's why we have to give the first two consideration. Radiography also we can detect, but in ultrasonic testing also the single porosity is very difficult to detection. So the best method is visual inspection, liquid penetrant testing, and radiography for porosity detection. This is wormhole, means there are hole occurs in the welding because of this shrinkage. It's not porosity. Porosity is small holes. So this wormholes image you will get in radiography like this. So it's not acceptable. So this we can detect by ultrasonics, radiography, magnetic particle testing, but most is ultrasonic testing and radiography. Now this slag inclusion. Now this slag means what? Now just imagine if you are doing SMAW welding. Now SMAW welding means this is the welding electrode, and this is the actually this is the filler wire, and surrounding the filler wire, around the filler wire there is flux coating. During the melting of this filler wire, this flux also melted, and because of this flux you will get the inert gases, and that gases will protect the weld metal or molten metal from surrounding gases. This is the purpose of this shielding. And but once you completed one run, we have to clean the weld, because we have to remove this flux from the weld. If you not remove, you will get the slag inclusion, and this is the main reason for slag. So this slag entrapped non-metallic inclusion during welding are only relevant on those welding process utilizing coated or flux electrodes, and mainly caused by insufficient cleaning between passes, wrong type of electrode contamination, travel speed too fast, and irregularities in edge preparation. So if edge is also, if edge preparation is not proper, then you will not see. So this main reason for the slag is flux coated electrode, these flux electrodes, because we are using flux to prevent the weld from environmental gases. So after flux this melted, it will generate the inert gases, and that inert gases will protect the weld from inert surrounding gases. So and after that we have to clean the weld once one run completed. If not cleaning and you are doing the second run, then there are chances of this slag will be more. Then cause of slag inclusion: inadequate cleaning between weld pass, travel speed too fast, poor electrode manipulation, wrong electrode type, and contaminated workpiece, and fluting of edge preparation, fluting of edge preparation. So these are the reasons, but main reason is inadequate cleaning between weld pass. This is the main reason for slag inclusion. And this slag inclusion we can detect with ultrasonic testing, radiography, magnetic particle testing, and penetrant testing also. So mostly we can use all methods, MT, this UT and RT. Now, I think less than 1 minute, we will stop and rearrange.